Math 1332, Chapter 3, Symbolic Logic, Section 2, Truth Tables, Video 7, Truth Table Example 2, Two Simple Statements. All right, not a whole lot to talk about at the beginning here. We've already done two simple statement truth tables, so we're going to jump right into this third one and construct a truth table for the compound statement. The negation of the conditional P pointing to negation Q. All right, so do you remember how we start? We start by using the hierarchy of connectives to determine the order that we're going to build our table. All right, so the hierarchy says go inside the parentheses first, but inside the parentheses are two symbols, a conditional and a negation. So now we have to go back to the hierarchy to know which one to do first. The after parentheses is negation. So inside these parentheses, we're going to do the negation first. That does not complete the parentheses because we have another connective, the conditional. It's the last connective in the parentheses, so that will happen second. That will complete the content of the parentheses, so we look outside the parentheses to see what to do next. Only one thing lives outside the parentheses, this negation, so it will happen third and last. So we're going to have 5 columns in our truth table, one for P, one for Q, and one for each of the connectives and negations in the statement. All right, let's get this table started. I thought about drawing the table while the video was paused to save time, but I want you to see the actual construction of the table. I know I'm going to need 5 columns, so let's go ahead and draw a rectangle here. Now, if you're doing this by hand, what I would do is not draw the right side of the rectangle until you know how wide you need each column to be. Maybe this isn't enough, maybe it's more than enough, but I'm going to make it work. Next, we need a column for P and column for Q, so let's cut off a couple of columns. I guess I could freehand draw this table, but I like taking advantage of the tools available in Zoom. Let's move that a little bit lower if we can. Give me 1 second to grab that line, move it down just a little bit. There we go. All right. So we already know that the first 2 columns are going to be for P and Q. And while we're at it, let's go ahead and populate them. You know what? Let's draw some horizontal lines. Might as well. I need to cut this into 4 rows. The easiest way to cut something into 4 pieces is to cut it in half and cut each half in half. They don't have to be perfectly spaced out. I'd be very surprised if they were, but that'll work for our purposes. All right, let's go ahead and populate the P and the Q columns since those are default. True, 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 false, false, true, false, false. Hopefully you know that ordering of those rows by now. All right, what is our first column going to represent? Our first column is going to represent the negation, and that negation belongs to the Q. All right, let's cut off that column. Okay. What will the next column represent? What is the second connective or negation that we're addressing? The answer is that conditional. I notice that my table is currently creeping up on this statement above. So let's see if I can grab the whole table and move it down. I can, yay me. All right, getting back to the next task at hand, our second column is going to represent the conditional. On the left side of the conditional is statement P. On the right side of the conditional is the negation of Q. And that will close off that column. So let's do that. And then our third and final column will represent the negation outside the parentheses. That negation and any negation always belongs to the symbol immediately to its right. The symbol immediately to the right of the negation is this parentheses, which means the negation belongs to that parentheses and its contents. So negation, parentheses, P conditional, negation Q. All right, there's half the battle, the setup. First column, second column, third column. All right. I invite you to pause the video and see if you can finish populating the columns by going left to right, and on each column, asking yourself 2 questions. Excuse me. Question 1, what rule am I using? Question 2, which previous column or columns am I using it? Am I doing it to? All right, I invite you to pause the video and give that a try. All right, hopefully you pause the video. If not, then get ready because I'm about to bust this table wide open. All right, for the first column, it was built on a negation. And what is the rule for negation? Is the easiest rule ever. The rule for negation is negation changes the truth value. Negation changes the truth value. So if it's true, make it false. If it's false, make it true. But which previous column are we going to change the truth values on? Well, who does the negation belong to? The negation belongs to the Q, which means I need to look at the Q's column and do that rule. Now, these columns are right next to each other, so there's really no need to cover up everything else. I'm going to just focus on it. It's like putting on blinders. All right, so looking at the Q column, we're going to apply the rule, change the truth value, and when we do that, here's what we get. When Q is true, its negation is false. When Q is false, its negation is true. True becomes false. False becomes true. So not too hard to populate. Negation is easy. Just look at it and change it. Let's clean this up. There we go. All right, let's move to the second column. What is the connective the second column was built around? The second column was built around the conditional. Remember, we decided that up here. So I need to apply the rule for conditional. What was the rule for conditional? The rule for conditional is it's false only when true points to false. I think that's the easiest visual way to represent that rule. So that's the rule that we're going to do. But which columns are we going to do it to? On the left of the conditional is the P. So we need its column. And on the right of the conditional is the negation Q. So we need its column. And if you notice in this example, there is a column between the 2 columns we need to focus on. So you need to cover it up. Either put your writing utensil over it, cover it with your finger, put a piece of paper over it. Don't scribble it out because we're going to need it later. Maybe, maybe not. But we need the P column and the negation Q column, and we're going to play out the rule false only when T points to F. Now, because there's a column between that's in the way, the 2 columns we're focusing on are not right next to each other, so it might help to draw the arrow from the P to the negation Q, from the P to the negation Q, from the P to the negation Q. Yes, it will make your paper sloppy, but if it helps, you do it. All right, so I know which rule I'm applying. I know which previous columns I'm looking at. What am I looking for according to my rule? I'm looking for T pointing to F. Are there any rows where T points to F? Yes, the first row. We have T pointing to F. So that is the only row with T pointing to F. So that is the only row that follows the rule that we're currently applying. When T points to F, our conditional is false. That's our broken promise. Again, it is the only row where we have T pointing to F, so it's the only row where we write false in the second column. The rest of the rows are true. Again, focus on the rule you're playing and the previous columns that you're doing it to. Let's clean this up. All right, now for the third and final column. Which connective or negation was the last column built around? It was built around the negation in front of the parentheses. So we're going to do the rule for negation. And just like before, the rule for negation was, just going to copy and paste this one. Negation changes the truth value. This is the rule that we're going to do. But which previous column are we going to do it to? The answer is whatever follows the negation. What follows the negation is the parentheses, which means that we are going to do that rule to this guy's column, but that guy's column is right here, the column that we just did. We're not looking at the first three, so let's cover them up for a moment. And this rule is easy to play out. This rule just says change the truth value. We are going to change the truth value of these guys. So what do we get? Change them and we get true, false, false, false. Let's clean this up. And at this point, the truth table is complete. I now know the truth values for this compound statement based on the truth values of its simple statement. When both P and Q are true, the compound statement is true. In all other cases, the compound statement is false. And some of you already know what I'm about to ask you. Where have we seen that column before? Where have we seen true, false, false, false before? Or equivalently, where have we seen true only when the two simple statements were all true? What connective has the rule true only when all simple statements are true? And the answer is conjunction. Now, it's not necessary to make these observations when you're asked to complete a truth table. In fact, it's completely unnecessary unless it's asked as a follow-up question. As a truth table question, the problem is over. But I'm trying to make you better thinkers, better observers, people that are good at drawing conclusions. So anytime you see something and go, wait a minute, haven't I seen that before? And if I have, what does that mean? It's a good idea, for the very least of which reason is it fires certain neurons in your brain, which literally makes your brain work better. Your brain is just like any other muscle. The more you work it, the stronger it gets. So by making observations, by drawing conclusions, by asking questions, your brain is becoming a better brain. You may not remember a single thing that I teach you once this class is over, and that's okay with me. I'm not expecting you to become a logician or a mathematician, but if I can make your brain better by making you use parts of it that you may not use as much as you could, then mission accomplished. So because this last column of this truth table is the same as the last column as the truth table for conjunction, we can definitively say the following. Now I'm about to use that phrase that I haven't defined yet, but by the time we get to it, I bet you can define it for me. Since the last column matches the last column of the table for P conjunction Q, we conclude that negation of P pointing to negation Q is, quote, logically equivalent, unquote, to P conjunction Q. Let's not put a line break there. All right, and again, I know this is kind of, let me try something real quick. Let's see if that'll fit right there. That may or may not be covered by my image. I'm not sure where my image is, so we're just going to do one more thing because I'm not done. I'm not done with this. Here's something I want to show you what this actually means. Here, give me 1 second to type this. If you got the truth table and you're not worried about the extension of this topic, by all means, in the video. But if you just want to become a better thinker in general, just give me about 60 more seconds. Even though I haven't defined logically equivalent yet, and we will because that's something before the end of this chapter, I want to show you what it means to be able to say things like this. Let's use a specific example. Let P equal, I won the lottery. I left out the equal sign. and Q equal I will marry you. What is this? This is I won the lottery and I will marry you. That one's easy. But what is this? Do you remember how to translate a negation in front of a parentheses with a compound statement? You say the phrase, it is not the case that. It is not the case that if I win the lottery, then I will not marry you. In other words, this statement is the opposite of this statement because of the negation in front, and we're saying that these statements are equivalent. So finding compound statements or statements in general that are logically equivalent in terms of symbolic, in terms of symbols, means that there are certain sentences that mean the same thing word-wise. So now you can kind of see how symbolic logic gives us the ability to compare statements. You said this. Excuse me, Mr. Politician, you said a sentence that looked like this. And then later you said a sentence that looked like that. Aren't you contradicting yourself? Well, let's do the symbolic logic. Both truth tables are the same. Nope, they're logically equivalent. Nice try, reporter man. All right, I dragged this one out a lot longer than I wanted to. So just to remind you, the point of this was to make the truth table, to make the truth table for this statement. And the minute we did this last column, that mission was accomplished.